So in this session, we will discuss the questions related to the redox and the transition element. The first one, in which of these ions does the metal oxidation number is +2? So the first one is written AlO2. So when we work out for AlO2 and the overall charge is -1 or 1 minus. So each oxygen is -2. So two oxygen will be -4. So because the net charge, so aluminum should be +3 because the net or result should be -1. So it cannot be A. Then we check the second one, the complex of a chromium. So chromium is there, two chloride, and then four water molecules are there. Water molecules, water is a neutral ligand, so it does not have any charge. Chlorine, one chlorine is -1, so two chlorine will be -2. But the net charge on the complex, it is +1. So if the net charge is +1, what should be the charge on chromium? That should be +3 because +3 -2, the net charge will be +1. Same way, if we have FeCN 6 raised to power 4 minus, so Fe is there, Cn 6, and the whole is 4 minus or -4. So each Cn is -1, 4 Cn will 6 Cn will be -6. So because the result is 4 minus, so it means Fe should be +2. So +2 minus 6, the result will be -4. That's why C is the right answer for this. Is it clear? Question 1. Then iodine is manufactured by reduction of iodide 5 ion in which IO3 with a charge using a hydrogen sulfide HSO3 in this reaction. The hydrogen sulfide ions are oxidized to sulfate by considering the relevant oxidation number and slash the number of the moles of hydrogen sulfide ion need to reduce 1 mole of iodide. So how we can identify this? First, we have to write a balance equation. So how to write a balance equation? As I mentioned, iodine is manufactured from iodide. So if iodine is manufactured from iodide, I2 is produced. So IO3, it is producing I2. That is one. And HSO3, with a charge of -1, it is producing SO4. Now we have to balance this equation. How to balance the equation? The redox equation, to balance the oxygen, we add water molecule. So we have 3, so we should add 3 water molecules. To balance the hydrogen, we add protons, so 3 to the 6, so 6 protons should be added. And this is having a whole is having a charge of -1. So +5 -1, the charge must be balanced because on the right hand side it is neutral, iodine is neutral, water is neutral. So how many electrons should be there to have a balance? So it means 5 electrons should be there on the left hand side. Then we have to balance this equation as well. On the right hand side we have SO4 with a charge, the sulfate ion is there with a charge of 2 minus or -2. So we have to balance this equation as well. To balance oxygen, we add water. So we add 1 water molecule, that is H2O, because 4 is there, 4 oxygen are there on the right hand side and 3 oxygen on the left. So we need 1 more oxygen. Then to balance hydrogen, we add proton. So we have 2 plus 1, 3 protons. So we should add 3 protons here. Sulfate is already balanced. Now we have to balance the charge. Overall charge is -1 and overall charge is +1 here, because -2 and +3, so +1. So what we want the overall charge or the net charge to be -1. because on the left hand side if it is -1, right hand side it should also be -1. So plus, it is +1 right now. How to make -1? So we'll add 2 electrons. So when we add 2 electrons, so first equation there are actually 5 electrons. The second equation there are 2 electrons. But to write a balanced equation, the number of the electron loss should be equal to number of electron gain. So what we have to do, we have to multiply this equation by 5 and we have to multiply this equation by 2 so that they will have the same number of electron loss and gain. So when we multiply this equation by 2, all the factors will be multiplied by 2. But the important is because we just need a ratio for iodate and hydrogen sulfide. When 1 mole of iodate is there, how many hydrogen sulfide? So when we multiply this equation, the top equation by 2, all the factors will be multiplied. But I'm just writing what we need as a reactant. So it will be 2iO3 minus 1. And when we multiply the bottom equation by 5, I'm just using that bottom part. So it is 5HSO3. Now the ratio between them, what is the simplest ratio? Because we need the, if 1 mole of iodate 5 ion is there, how many moles of HSO3? So the simplest ratio between them is 2:5. According to the combined equation, what we write here, the simplest is 2:5. But if we 1 mole is there, this will be x cross multiply. So 1 will be 2x is equals to 5 or x is equals to 5 by 2. So it will be 2.5. Is it clear? So an electrode system and a diagram is there for half cell. Manganese 4 oxide is there, or potassium manganate ion is there in the solution. It turn into Mn plus 2. Identify the oxidizing agent and half cell equation. So how we can identify the oxidizing agent? Oxidizing agent is a substance which help in oxidation. By itself it is reduced. So when we check the option, MnO4. So what is the oxidation number of Mn here in MnO4? Each oxygen is -2, so 4 oxygen will be -8, so Mn is +7. And during a reaction, it changed to Mn plus 2. So if +7 changed to +2, so if +7 is changing into +2, it means this change is a reduction. And for substance which reduction happened, that is an oxidizing agent. So what is an oxidizing agent here? Oxidizing agent is MnO4 with a charge -1. And whenever there is a change in the ion, only the valency changes. Like the metal is not formed or metal does not turn into iron. So what we use this as an inert electrode. So what is the material inert electrode is made up of? So inert electrode is made up of platinum. That's why A is the right answer. Why not manganese electrode is used? Manganese electrode will be used if there was a change, like if there was Mn changes to Mn plus 2, or if there was Mn ion is there changing into Mn atom. So it's not forming an element. It is like element is not forming an ion, or ion is for not forming an element. Here what happened? The only thing, there is a change in the oxidation number. So whenever the change in oxidation number happen or occur, that happen within the solution. So electrode does not need to provide those metal atom or ions. That's why it should be inert. So we are using platinum. As well as the water, which component must be present in Y? So what should be present? As you can see here, because it's a reversible reaction. So if it's a reversible reaction, reactant can form a product can form back the reactant. So you can see as a reversible reaction, what are the ions should be present there? Because we don't know, maybe MnO4 with a charge -1 might change into Mn+2, or Mn+2 might change into MnO4 with a charge -1. Both changes can occur. As we don't know, that's why if other than water, what ions should be there? So should have MnO4 should be there. It should have Mn+2 and as well as protons. So from where protons will come? From acid. So that's why D is the right answer. So all of these ions should be there. As reaction is reversible, reactant can form a product and product can form back the reactant. Is it clear? So another question: for any reaction, electrode potential of a cell, the cell voltage basically, because it is standard uh, voltage of the cell is related to entropy and also related to K. So the equation which relate these two, they are directly proportional. Like entropy, if a higher entropy is there, higher cell voltage. Same thing, higher value of a K, it will have a higher cell voltage. If equilibrium is shifted towards right, more product will be there. So electrode potential of a cell or the cell voltage is directly proportional to both, because the formula is it is equals to total entropy ln K. So means if the total entropy increases, the cell voltage will also increase. If ln K increases, the cell voltage will also increase. It's not directly proportional to K, it is ln K. If ln K is double, the value of cell voltage will be double. So that's why D is the right answer. In ethanol fuel cell, ethanol is. So what happened, like different types of fuel cell we have hydrogen fuel cell, we have methanol fuel cell, and we have ethanol fuel cell as well. So what happened in a fuel cell which consists of ethanol, because alcohol, methanol or ethanol fuel cell, they're oxidized to, as this will be the electrode. So when we add ethanol C2H5OH, so when this C2H5OH added, and we have oxygen from other side. So as a result, what will happen? Oxidation is a loss of electron. So it loses electron. And what is the overall equation? When I represent the overall equation, like ethanol will be oxidized to ethanoic acid. So first ethanol is there, it will turn into C2H5COO or CH3COH, ethanoic acid. And oxygen is there. So the terminal, whenever oxidation always happen at anode. At cathode, oxidation cannot occur. So this is the overall equation. What happened in ethanol fuel cell? Like we have electrodes, two electrodes. So ethanol is there in the presence of water from carbon dioxide, proton, and lost two electron. And oxidation is a loss of electron. So oxidation happen. So ethanol is there, C2H5OH. In the presence of water, H2O, three water molecules are there. The electrons are lost, and these electrons will travel. And when these electrons will travel, electron will be here, the oxygen and the protons which are reduced here, like loss, they will combine together, and as a result it will produce water. So ethanol fuel cell gives carbon dioxide and water as a product. Now, in terms of movement of electron, where the electron are moving, that is called a negative terminal, and the other one is called positive terminal. This is in terms of movement of electron. But always remember, oxidation can happen only at, in terms of oxidation, oxidation is a loss of electron. So oxidation always happen at anode, and reduction, which is the gain of electron, it only happen at cathode. So student get confused that in terms of movement of electron is a negative. So we should say that this is a cathode and this one is anode. But it's not like this. This negative and positive is in terms of movement of electron. But in terms of loss or gain or oxidation or reduction, oxidation always happen at anode and reduction always happen at cathode. That that is why in option A, the ethanol is oxidized, and when ethanol is oxidized, where oxidation happen, we don't say a cathode, we say that as anode, because in terms of oxidation, anode always oxidation occur. So in ethanol fuel cell, the ethanol is, so what happened to ethanol? So electrodes are there, they're connected by the wire, and we can have any component to use that energy. So this ethanol C2H5OH, when it moves, it break down into what? It gives carbon dioxide, it gives protons, and it gives electron as well. Because oxidation is a loss of electron. So over here what happened? Oxidation happened because it lost electron. And what happened to these electrons? These electrons will travel because like charges repel. So electron travel from negative terminal to the positive terminal. So in terms of electron movement, electron always travel from negative terminal to the positive terminal. This is in terms of movement of electron. So in a chemical cell, the negative terminal, we don't say cathode, we say negative terminal. Negative, because it is in terms of movement of electrons. So the negative terminal of a chemical cell is the one where the electrons are lost, and the positive terminal is the one where the electrons are gained. So the movement is always from positive to negative. So when ethanol is there, it loses electrons, so it is oxidized. Then always remember, then this what will happen? Oxygen will gain electrons. So for oxygen, there will be reduction happen because it gain electron. So one side oxidation happen, another one reduction happen. And in terms of oxidation, the oxidation always happen in terms of oxidation. What is this electrode known as? In terms of oxidation, this is known as anode, because at anode always oxidation happen, always there is a loss of electron. So in terms of oxidation, this is anode, and so oxidation always occur at anode, and in reduction it always occur at cathode. So in terms of oxidation and reduction, this is anode, other one is cathode. But in terms of movement of electron, this one is a negative terminal, this one is a right one is a positive terminal. So it depends on, in a chemical cell, the negative electrode is refers to anode. Negative in that sense, in terms of movement of electron is in negative, but because oxidation happen and oxidation also occur at anode, that's why this is known as anode. So in ethanol oxygen, in an ethanol oxygen fuel cell, ethanol is oxidized, and where it is oxidized, it is always oxidized at anode. Is it clear? Another question: which element could form a colorless ion with an oxidation number of +4? So how to identify how it can form a colorless ion with oxidation number of +4? We have to check the periodic table, and we have to write the electronic configuration first for that element. So example, the first one is titanium, which is 22, the atomic number. So 22 atomic number, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Now what happened when there's a loss of electron orbital lost from the last cell. So first 4s will lose, then 4s will lose, then 3d will lose, and then another 3d. So all these orbitals will not be there because the is lost. So now it is having a configuration 1s2, 2s2, 2p6, 3s2 and 3p6. So it does not have partially filled d orbital. So if it does not have partially filled d orbital, what will happen? It does not form a colored compound. So that's why it will be A. But when we check for manganese, manganese is having atomic number 25. So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 5 will be there. So when electrons are lost, electron will be lost 2 from here and 2 from this one. So it will have, in a d, it will have 4. So it is having a partially filled d orbital. That's why it will form a colored compound. And like this, it will happen for rest. For titanium, because there is no partially filled or incomplete d orbital, that's why it does not form a colored compound. Is it clear? The conversion of sulfur dioxide to sulfur trioxide is catalyzed by vanadium pentoxide V2O5. So how they are acting as a catalyst, like catalyst is a substance which chemically remain unchanged, and there are two ways the catalyst can alter the rate of the reaction. Number one, it can absorb the reactant on the surface, reduce the strength of the reactant, and as a result, when it reduces the strength of the reactant, the bond in the reactant, the bond can break, so it lowers the activation energy and the product can form. That is one way. The second way is by changing their oxidation number, because the transition element, their successive ionization energies are closer, so they can easily oxidize and reduce. So they take electron from one substance. When they take electron, they are reduced, and then they lose electron to another substance, so they're oxidized. So like it's an intermediate path. So we have vanadium pentoxide V2O5. So it might take electron from one material or loses to the other. So overall it won't change. Or what might happen, opposite can also happen. So we have to identify from which substance it will gain electron and which substance it will lose to. So the mechanism of this reaction is most likely to involve reduction of vanadium 5 to vanadium 4 by oxygen, followed by oxidation of vanadium 4 to 5 by sulfur dioxide. So when we check sulfur dioxide, what is the oxidation number of sulfur? Each oxygen is -2, so 4 oxygen will be -4, so sulfur is +4. So sulfur is +4, as sulfur belongs to group 6. Group 6 maximum it can be +6 and minimum it can be -2. So it can vary from -6, -2 to +6. So sulfur can change to +6, sulfur can change to -2. But as you can see in the reaction, what is happening in the reaction, if you see, sulfur is +4 and here sulfur become Each oxygen is -3, so 3 oxygen will be -6, so sulfur become +6. So sulfur is +4 changing into +6. So for sulfur, what is happening? It is oxidation. So oxidation should happen for sulfur. If oxidation is happening for sulfur, then when it should reduce the vanadium. Because if sulfur is oxidation happening, it should reduce the vanadium. And for oxygen, what is happening? Oxygen, because element is there in element state, oxidation number is 0 and each oxygen become -2. So for oxygen, reduction is happening, so it should oxide, because if reduction happen for element, it will oxidize the other substance. So what happened when we read option A cannot be correct, because it is mentioned vanadium is reduced by oxygen. Vanadium can, if oxygen is reduced, then if oxygen is reacting with vanadium, it cannot reduce vanadium, it can oxidize vanadium. That's why A cannot be an answer. When we check the second, reduction of vanadium 4 to vanadium 5, first vanadium 4, vanadium 5 become vanadium 4, reduction of vanadium 5 to vanadium 4 by sulfur dioxide. That's true, because if sulfur dioxide is oxidized, it will reduce the vanadium. So it's like sulfur dioxide first mixed with vanadium pentoxide V2O5, and it will form SO3, like sulfur is +6 is formed and vanadium is +4. And this vanadium +4 reacted with oxygen turned back to vanadium +5, because oxygen is reduced. If oxygen is reduced, vanadium should be oxidized. So reduction of vanadium 5 to vanadium 4 by sulfur dioxide, because in this example sulfur dioxide is oxidized, so it will reduce vanadium. And then when vanadium is reduced, it has to return back, because it is a catalyst. Catalyst chemically remain unchanged, so it has to return back to the same oxidation number. How it returned back to the same oxidation number? By reacting with oxygen. So vanadium 4 returned back to vanadium 5, because oxygen is reduced, so it will oxidize the vanadium. So B is the right answer. Is it clear? So in this question, chromium is classified as transition element because, so what is the classification? It is a D block element. All D block elements are not transition, like zinc is there, even it's a D block, or scandium is there. It forms stable ion in which it has different oxidation numbers. So the idea is that there are many elements which can form stable ions. So they have variable oxidation number. That is true, but that is not the specific, like we said, a definition for a transition. It is true, but not explaining the whole concept of a transition, that they should form a stable ion with incomplete d orbital. Even like example, we have elements which can have a different oxidation number and they are forming stable ions, but they are not classified as transition. It has incompletely filled d orbital, but that is it is true, but that is not explaining the idea. For to be a transition element, it should form a stable ion and having the incomplete d orbital. Like d orbital is still incomplete, but the ion which is formed is very stable. So that is a characteristic of a transition element, that they form stable ions with an incomplete d orbital. So D is the right answer. Then the next question, it's about series below shows the first force ionization of different element, which could be those of transition. So transition element, their ionization energies, successive ionization energies, or across the period, it is comparable. So comparable means like change approximately with the same ratio. This is 496, it becomes 4000, then 6900. So this is a big jump, big changes there. So that is why it's not correct. 578, it is about 3 times, then it become double, and then see the very big jump from 2745 to 11,000. When you check option C, 658, double is about 1300, double is 26, double is about 5200, but it's in the same order, like same range. But why not D? So C is the right answer for this. Why not D? Again, when you check for D, 738, double is 1400, that's correct. But then there's a very big jump from 1400 to 7000. So for these transition element, when we move across the period, the ionization energies of successive transition elements are comparable. So C is the right answer for this. Then which of the following are oxidation states of a chromium ion? So water is a neutral ligand. So OH is there. So each OH is -1. So 6 OH will be -6. Because the overall is having a charge of 3 minus. So chromium should be +3. And here in CrO4 with a whole charge of -2. So each oxygen is -2, 4 oxygen will be -8. So to get -2, chromium should be +6. So chromium +6 and here +3. That's why B is the right answer. In this question, metal M is there. React with a nitrate in acidic condition and the product is Mn with a charge of N plus. Like N can be any number. The ratio and to give a water and nitrogen dioxide. The reacting ratio for M atom to nitrate is 3:2. So basic idea is that the number of electron lost by one should be equal to number of electron gained by the other. If the ratio is M, like 3 moles of M reacting with 2 moles of nitrate ion, produce this Mn, not Mn, M basically, it's a metal. So M raised to power N plus nitrogen oxide, NO is there, plus H2O, water is there. So the number of electron lost by one should be equal to number of electron gained by the other. So first we have to find how many electrons are being lost. So how to know or how many electrons are gained? So we have to check the oxidation number of, because for nitrogen there is a change in oxidation number. First it is NO3 with a whole of charge -1, then it becomes NO. So when we check, because each oxygen is -2, so 3 oxygen will be -6. Overall charge, it is -1 on nitrate, so nitrogen should be +5. So here in nitrate, the nitrogen should be +5. In NO, forming NO, this is -2, so this should be +2 because the overall compound is neutral. So +5 changes to +2. So if +5 changes to +2, it means it is gaining how many electrons? It is gaining 3 electrons. That's how, but this is for one. If one nitrate ion is gaining 3 electrons and turn into NO, so if we have 2 nitrate ions, according to question, if 2 nitrate ions are there, how many electrons they should gain? If one is gaining 3, the 2 nitrate ions should gain 6 electrons. So if nitrate ion is gaining 6 electrons, the metal should lose 6 electrons. So if three metal atoms are losing 6 electrons, and turn to an ion, so if 3 metal atoms are losing, so one metal atom should lose 1 electron. If 3 metal atoms are losing 6 electrons, so one metal atom should lose 2 electrons. So what should be the charge here? The charge for the metal, it should be 2 plus or it should be plus 2. That's why B should be the right answer. So first we work out how many electrons nitrogen gain when it converts from nitrate, like in nitrate with a valency +5 to NO with a valency +2. So each nitrogen gain 3 electron, but there are two nitrogen, so they will gain 6 electron. If they gain 6 electron, the metal should lose 6 electron. We have 3 atoms of the metal. If 3 atom loses 6 electron, so one atom will lose 2 electron. And when one atom is losing 2 electron, what will be the charge? The charge will be 2 plus or plus 2. In this question, use the electrode potential to answer the following questions. Different electrode potentials are given to us, and the question is, which is the strongest oxidizing agent? Oxidizing agent itself, it is reduction happen. And how the reduction happen? Reduction is by gain of electron. So oxidizing agent by itself, it is reduced by gain electron. So the question is, which one can gain electron easily? So we are having option vanadium plus 3 is there, vanadium plus 2, chlorine is there, and chloridine. So how we can work out? We have to check these numbers. If vanadium 3, look, because the equation is to gain, whenever electrode potentials are given, they are always to gain electron. So electrode potential for vanadium, it is negative minus 0.26. It means opposite is valid, like vanadium 2 can easily lose electron instead of vanadium 3 gain electron. So it cannot be this one. Then for vanadium 2, the voltage will be, because if vanadium 3, when we work out the charge here for vanadium, like because vanadium is plus 3 gain electron turn into vanadium 2. So vanadium 2 is basically, it's not reduced, it is oxidized because it is losing electron. Oxidation is a loss of electron. So vanadium 2 is not an oxidizing agent, it is a reducing agent because it is oxidized by itself. It can oxidize as the negative voltage is there, it means reverse is more feasible than the forward. Then we are left with chlorine and chloridine. So for chlorine to gain electron, it is 1.36. And for chloride to gain electron, chloride does not gain electron, chloride will. If the forward here, as you can see, the chlorine molecule turn into chloridine, the voltage is plus 1.36. Means the reverse is not, like, less feasible. So it means the chloridine cannot lose electron easily. And for oxidizing agent, reduction it should happen, or reduction is a gain of electrons, so it should gain electron. So chloridine is already negative charge, so it cannot gain electron, it can only lose electron. That's why C is the right answer. And which species would convert the vanadium 4 to vanadium 3 under standard condition? So we want to convert the vanadium 4 into vanadium 3. So when we check the options, vanadium 4 to vanadium 3, that is a reduction. Reduction happens, so we are looking for oxidizing agent. So how to identify the oxidizing agent? Already we checked all of this. So chlorine molecule is a reducing agent because oxidizing agent by itself it is reduced. So vanadium 4 convert into vanadium 3. So this change is a reduction. So we are looking for oxidizing agent. Under the standard condition, so electrode potential, like as in the question, the chlorine is there, but under standard condition, we want to convert this. Chlorine is a strong oxidizing agent. So if we use chlorine, so it will reduce this vanadium to further lower oxidation number. So when we check the options, Which equation vanadium 4? First we have to check which equation vanadium 4 is converting into vanadium 3, so that we can compare the equations. Here each oxygen is -2, so vanadium should be +4. So vanadium +4, it is converting into vanadium +3. So vanadium +4 is converting to vanadium +3. So 0.34 is there. And electrode potential of a cell, it is reduction minus oxidation. So reduction, when we work out the reduction here, reduction is because vanadium 4 tending to vanadium 3, that's a reduction. So that is 0.34 minus. So oxidation, here which substance oxidation happen? So if we have, like, when we check the options, the first one is V plus 2. So V plus 2, because vanadium plus 3, like this is the first equation. If we say A and this one is B, so if there is a reaction between them. So the one which is a higher potential, that is oxidation happen, minus the one which is a higher potential reduction happen, minus the oxidation. So when we write the oxidation, so it will be minus 0.26. So 0.34 minus minus plus 0.26. So 0.34 plus 0.26, what will happen? It will be 0.6 volt. So we'll get a positive voltage. It means the vanadium 2, the solution of a vanadium 2 can change this vanadium 4 to vanadium 3. But what about iodide? When we check for iodide, like if there is a reaction between iodide, so this one is A, this one is B. So when we compare these two equations, this is a higher potential. So this one reduction happen, other one oxidation happen. Means vanadium 3 will turn into vanadium 4. So mean that is not possible. We don't want that. So that's why iodine cannot be used. What about chlorine? So when we checked with the chlorine, so as you can see, 1.36 and 0.34, again this is a higher voltage. So for this one reduction happens, so this will be oxidized. Oxidized means what will happen, because always reduction potentials are there. So oxidized means reverse will possible. 3 can convert into 4, 4 cannot convert into 3. Same thing if it is reacting with a chloride ion. Like the chloride is a reactant here. The chloride ion Cl charge is a reactant. So this will become minus 1.36. And what about the vanadium? So it will be plus. But when we work out the total electrode potential, it will be very high. Like example, when we are reacting here, the chloride ion, because the chloride ion is a reactant. So if chloride ion turn into chlorine molecule by loss of electrons, so vanadium 4 V4 will gain electron and turn into V3. But further possibility is there. What is the second possibility? You can see here vanadium is, in this question, this is vanadium plus 5, and here vanadium plus 4 is also there. So this can convert, because this is 1 and this is minus 1.36, or we can say that if chloride ion is losing electron, the vanadium plus 5 can still gain electron. So reverse, the second possibility is also there. That's why the chloride is not correct as well. So the question was, which species would convert the vanadium 4 to vanadium 3 under standard condition? So under standard condition, when vanadium plus 2 reacted with vanadium 4, it will convert that into vanadium plus 3 because the cell voltage will come out positive. Is it clear?